And I'm starting it early is to give you guys ample time to be creative and to just have fun with it. So the last lesson is going to be intersections of two lines. Obviously, in grade 9, and not in grade 9, in grade 10. Well, in grade 9, you've discovered intersections of lines graphically, but in grade 10 is when you start to get into it algebraically. So, who remembers how to find the intersection of two lines? What do we do? How do we figure that out algebraically? What do we use? Come on, guys, grade 10 math. What do we use to figure out the intersections of two lines? A system of equations, which means we're going to be using elimination or substitution. Is there always going to be a point of intersection? There is not always going to be a point of intersection because lines can be parallel. So for the first example, pretty easy. You want to find the intersection of the lines 3x plus 2y is equal to 2 and 4x plus 5y is equal to 12. And thank you, Priyanshu. But because we're talking about two lines in the specific one, yeah, you're right. There will never be there are possibilities where there's no solution because the lines are parallel. So we have our first equation, which is 3x plus 2y is equal to 2. And we have our equation 2, which is 4x plus 5y, which is equal to 12. So we need to manipulate this into a way in where we can either get the x's to be equivalent to each other or the y's to be equivalent to each other. Usually what you do if they're not even numbers, if it's an odd and an even, is you just multiply the first equation by whatever coefficient is in front of the x for equation 2 and vice versa. Then when I multiply equation 1 by 4, as you noticed, 4 is the coefficient of x in the second one. And I'm going to multiply the second equation by 3, which is the coefficient of x in the first equation. So what I get is 12x plus 8y is equal to 8. And I get 12x plus 15y is equal to 36. So now I'm going to subtract. So these guys go. 8y minus 15y is negative 7y. And 8 minus 36 is negative 28. And if I isolate for y, I get y is equal to 4. So I found my y component for my point of intersection in this system of equations. So now to figure out what my x value is, let me just sub in y is equal to 4 to my first one. So I get 3x plus 2 times 4 is equal to 2. 3x plus 8 is equal to 2. 3x is equal to negative 6. X is equal to negative 2. Therefore, my point of intersection is negative 2 and 4. So the possible scenarios of lines in the planes and space. So lines in a plane, so this is a 2D space. I can have lines going from here to here, and here to here. And as you can see, there is one point of intersection. So these lines can be intersecting. which means I have a point of intersection somewhere, and that's in those two lines. My next one can be parallel and distinct lines, which means that there is no solution and that the lines will never meet or intersect. And the last one I have is coincident lines. I gotta use two colors for this to show you guys, which means that there are multiple points of intersection. Every point is a point of intersection in this one. So lines in space can be intersecting, they can be parallel or distinct, and they can be coincident. And in the 3D space, they can be called skew, which means there is no point of intersection. It's going to be hard to draw this out in a 2D model because you have to see the 3D. However, they're not parallel. But the lines lie in parallel planes. This is going to be very difficult to draw. So for example, I can have one line that goes like this. I can have another line that goes like this. Then I can have a line that goes like that. So I know it's hard to see it graphically, but when I show it algebraically, it'll become easier to understand that sometimes lines cannot be coincident or they can be skewed. So again, this will make more sense once we start doing things algebraically. So we just saw that if the equations are scalar form, we still use elimination or substitutions to solve. But what if the equations are in vector, parametric, or symmetric form? So the first one, I want to find the intersection of lines. So my first one is at negative 2 plus t times 3 negative 2. The next one is negative 5 comma 4 plus s times 2 negative 1. So again, because they're different lines, we have two different parameters, t and s. So we want to write both lines in parametric form first. So that's going to be our first step. So we'll label this guy line 1 and the bottom one line 2. So for line 1, my x is going to equal 18 plus 3t. My y is going to equal negative 2 minus 2t. For line number 2, my x is going to equal negative 5 plus 2s. Then my y is going to equal 4 plus s. So now what we need to do is we need to set my x components equal to each other on both lines and same with my y components. I hope you guys can understand my writing. Can you guys read that? Okay, Madge, what does the last part say? Yeah, equal to each other. There we go. So for my x components, I'm going to get 18 plus 3t is equal to negative 5 plus 2s. I want all my variables on one side and all of my constants on the other side. So I'm going to get 3t minus 2s is equal to negative 23. Now for my y's, so I'm going to have this is going to be one part. And then I'm going to get 2, or negative 2 minus 2t is equal to 4 plus s. So I get negative 2t minus s is equal to 6. However, I can just start using substitution, and I can isolate for s, sorry. So I get negative 2t minus 6 is equal to s. So now I'm going to sub this guy for 1. So I get 3t minus 2 times negative 2t minus 6 is equal to negative 23. So I get 3t plus 4t plus 12 is equal to negative 23. And I get 7t is equal to negative 35. Divide both sides by 7. And I get t is equal to negative 5. So now I'm going to solve. Now I need to solve for s. So I'm going to use this equation and sub in negative 5 for t. So I'm going to get negative 2 times negative 5 minus 6 is equal to s. 10 minus 6 is equal to s. S is equal to positive 4. So in order to figure out if t is equal to negative 5 and s is equal to 4 is correct, I need to sub these guys. And just sub for both parameters. In both lines. So when I sub in for s, when I sub in negative 5 for t in the first one, my result is going to be the 0.3 and 8. And when I sub in 4 for the second line, for s, I'm going to get 3 and 8 again. So my point xy is going to be 3, 8. I'm going to use a different color because the red is getting boring. And now for example 3, again, we're going to be doing the same thing. Let's find the intersections of the lines. So again, we have everything in parametric form. Now I'm just going to get my x is equal to each other, my y is equal to each other, and my z is equal to each other, and come up with simplified expressions and use substitution or elimination. So for my first one, I'm going to use my x's. Negative 1 plus 3t is equal to negative 1 plus 2s. And this is going to give me 3t minus 2s is equal to 0. So we have my first equation. My second equation is going to involve my y's. So I get 1 plus 4t is equal to 3s. So 4t minus 3s is equal to negative 1. That is for my y's. And last but not least, it has to do with my z's. So I get negative 2t is equal to negative 7 plus s. Negative 2t minus s is equal to negative 7. Perfect. Now what we're going to do is we're going to pick two of my parameters, not parameters, two of my components to use. And let's use my x and y components. So we're going to use these two. So we're going to use those two. Now, I can't isolate for S or T because I have a coefficient and I really don't want to work with fractions. However, I can use elimination. So again, I'm going to multiply the first guy by the coefficient of T in the second one. It's going to multiply this guy by 4 and vice versa, multiply this guy by 3. Which means I get 12T minus 8S is equal to 0. And then I get 12T minus 9S is equal to negative 3. Again, I'm going to subtract, cross out, negative 8S minus negative 9 gives me S is equal to 3. So I have my first parameter, which is S is equal to 3. So because I'm using my first two components, X and Y, I can only sub in S equals 3 for either my first equation or my second equation, but not my third, because I have not used that. So I'm going to get 4 times T minus 3 times 3 is equal to negative 1, which means 4T minus 9 is equal to negative 1, 4T is equal to 8, T is equal to positive 2. So because this works for the first two equations, I don't have to check that my solution works, because I can assume it works because it's S equal to 3 and T is equal to 2. But now I need to check if it satisfies my third equation. So now I have to sub in S is equal to 3 for Z, and T is equal to 2 for Z as well. So I have negative 2T is equal to negative 7 plus S. I know my T is equal to negative 2, so negative 2 times 2. So all I'm doing is checking my left side is equal to right side. And then I know my S is going to be 3. So negative 7 plus 3, so I get negative 4 is equal to negative 4, which means that this satisfies 3. So now, whichever one I plug in, I can use T or S for all of them, they're still going to give me the same point. So if I sub in 2 for T, my point of intersection is going to be this. So the first one is negative 1 plus 3 times 2, which is negative 1 plus 6, which is going to give me 5. The next one is 1 plus 4 times 2, which is 8. So 1 plus 8 is 9. And the last one is negative 2 times 2, which is going to give me negative 4. So you can also do the same thing with S. Negative 1 plus 2 times 3 is going to give me 5. 3 times 3 is 9. Negative 7 plus 3 is negative 4. So as you can see, S is equal to 3 and T is equal to 4. Satisfies every single one of those parametric equations, and it gives me the same point of intersection for each one, which means that those solutions do work. And now we're going to finish off this lesson by doing one more example. So we have find the intersection of the lines 2, 1, 0 plus T, 1, negative 1, 1, 3, 0, negative 1 plus S times 2, 3, and a negative 1. So again, same thing. Set our x's equal to each other. So you get 2 plus T is equal to 3 plus 2S. T minus 2S is equal to negative 1. Okay. Equation 2. Now I'm going to deal with my y's. So I get 1 minus T is equal to 0 plus 3S. So I get negative T minus 3S is equal to negative 1. And then the last one has to do with my z's. So I get 0 plus t. So I just get t is equal to negative 1 minus s. So t plus s is equal to negative 1. So now I can use elimination with these two. So I get t minus 2s is equal to negative 1 minus t minus 3s is equal to negative 1. So I'm going to add these guys together. T plus negative t gives me 0. Negative 2 plus negative 3s is negative 5s. Negative 1 minus negative 1 gives me 0, which means s is equal to 0. So if I were to plug that in for s, I'm going to get t is equal to negative 1.
Sir,
Oh, yeah.
The negative ones, aren't you adding them?
Negative 1 plus 1. Whoops. This one's positive 1. That was my bad. I completely messed this one up. Positive 1, positive 1. So yeah, t is equal to positive 1. That was my bad. Yep. So now I need to check my third equation. So I have t is equal to negative 1 minus s. I need to check if left side is equal to right side. So I know t is positive 1. So I get positive 1 on the left is equal to negative 1 minus 0. So I get 1 is equal to negative 1, which is not possible, which means that these lines are skewed because the direction vectors are not collinear. It's not a complete lesson with me if I don't make a mistake on a question. I think I've always made a mistake on the question because I'm either going too fast or not paying attention. And then for the last thing, so the intersection problems considered have been examples of linear systems. A linear system is a set of two or more linear equations that may involve thousands of equations. A linear system of equations may have no solution. So this is an inconsistent system. It can have one solution, and it can have many solutions. So the linear system is said to be consistent if it has at least one solution. Otherwise, the system is inconsistent, which means it has no solutions. So now what we're going to do is I'm going to go over the CPT with you guys. Like I said, it's not